now we're going to be simplifying radicals that have variables in them. Oh no, you say. Well, yeah. So look at this one. We know that the trick is you're dividing by the index. So this is a square root. So if I divide by the index, 2 goes into 6 3 times with none left over. All right? 2 goes into 6. 2 divides into 6 3 times with none left over. 2 divides into 10 5 times with none left over. That's the answer. So if the index divides into the number evenly, there's no square root left over. How about that, huh? How about that? Now, in the book, they'll put if it's an even power with an odd answer, you're going to have to do the absolute value of everything. I don't think. Yeah, absolute value of everything. So the answer is the absolute value of this. That's what we're looking for. Okay, let's try again. Let's do cube roots this time. Cube roots, a to the 15, b to the 18. Woo-woo! 3 dividing to 15? It does. 3 divides in there 5 times. 3 divided into 18? It does 6 times. Now, if it's an odd root, like a cube root, you don't need the absolute value. So that's totally fine, right? The only time you need an absolute value is if it's an even root and your answer is an odd exponent. Okay? Ta-da! Let's do some more. What if our problem didn't divide in there evenly? Oh no. Yeah. 2 into 5. Now remember, it's kind of like long division. 2 goes into 5 2 times with 1 left over. See, this is your remainder. Remember that? Well, if 2 goes into 5 2 times with 1 left over, then that means one of the m's have to stay in the radical and the other 2 can come out, right? How about 2 divides into 3? 2 divides into 3 one time with 1 left over. And so this whole thing here would be the answer to this problem, right? The square root of this guy divides in there evenly. Let's do cube roots. Let's see. Cube roots of P11 and Q8. Aha. Now, 3 goes into 11. 3 goes into 11 3 times with 2 left over. How about that? So P to the third comes out. The quotient goes on the outside. And P to the second stays underneath. Right? How about this? 3 goes into 8. Well, 3 goes into 8 2 times. 2 times. That would be 6 with 2 left over. Look at that. How about that? Amazing, huh? Totally and completely amazing. Let's do it with numbers and letters. Now, you've been doing numbers here just yesterday. You were doing numbers, so you shouldn't have any trouble with numbers. Let's try. Let's try one with numbers. Cube root of 54. And then x9, y11. Okay, so remember you have to know the cube roots. Now you can set your calculator up. If you just do this, if you say y equals, and you type in x raised to the third power, just like that, x raised to the third power, and then you go to your table, then you'll see all you need to start there. We need to start our thing at 2. We want to start at positive 2. And then we can see the perfect cubes. 8, 27, 64, 125, 216. Look at all those perfect cubes. So we've got 2 is 8, 3 is 27, 4 is 64, and we don't need any bigger because 54, which one is divisible? I think that's 27. So this is 27 times 2, right? That's what that is. So do you know the cube root of 27? Yes, I do. It's 3, right? All right, now then that means that the 2 I don't know the cube root of, right? How about 3 divides into 9? Hey, 3 divides into 9 evenly with none left over, so there's not any x's in here, right? Oh, come on. There we go. 3 divides into, cube root of 27, we know 27 is the perfect cube. And so 27 is 3, 2 has to stay underneath. And then the cube root of 9 is 3. Yay! X to the 9th. How about the cube root of y to the 11th? Well, you're dividing, right? 3 goes into the 11 3 times with 2 left over, right? This would be the total and complete answer. Don't forget your little index there, and you're in business. Let's do it again. See if we understand what's cooking. Okay? So we'll do a cube root again. 56, and we'll do M5, N3, and P1. How about that? Now, 56. Is 56 divisible by 64 or 27? No. How about 8? I think so. 56 divided by 8, that is 7. So this is the cube root of 8 times the cube root of 7. How about that? Well, I know the cube root of 8. The cube root of 8 is 2. And I do not know the cube root of 7. So 7 stays under the radical, 2 comes out. Okay? What about, does 3 divide into 5? Yeah, 3 goes in there 1 time with 2 left over. Does 3 divide into 3? Yeah, it goes in there 1 time with none left over. Does 3 divide into 1? No, it can't. So that means that stays there. Right? If the number inside is smaller than the index, then that number doesn't move, right? If the number is bigger than the index, you divide and write down how many times it goes in and how many is left over, right? Yay! We did that without any trouble. Let's do a square root. We haven't done a square root in a while. Let's do a square root. Okay, how about this one? The square root of 125 times x, y, z. Okay, now this is square root, right? So instead of x cubes, you want x squareds. So 2 would be 4, 9, 4 would be 16, 5 would be 25. So let's see. Well, we know 25 is the number that divides in there, right? So 25 goes into 125 5 times. What am I saying? 5 times. So the square root of 25 times 5 times 25, that's 125. How about that? Okay, so what does that mean the answer is? Well, do you know the square root of 25? Yes, I do. Do you know the square root of 5? No, I do not. Whoops, putting that right in the wrong spot. Let's move this over here. 5 and 5. Okay. Now then, can I divide 2 into 1? Remember, this is a 1. Remember, if this is smaller than that, then that can't move. So x doesn't move. 2 divides into 2 1 time exactly. Yay, none left over. 2 divides into 3 1 time exactly with 1 left over. right? Now, if you want the little ones in there, you can. You don't have to. That would be the answer. Wow, how about that? Woo, woo, woo. Let's try a fourth power. A fourth power? You're crazy. No, I'm not crazy. A3, B6, and C9. How about that? Okay, so now what do we need? We need x to the fourths, right? We need x to the fourth power. What is that? Well, remember the easy way to do it is just go to y equals, make this say x raised to the fourth power, just like this. See if I can remember. There we go, x raised to the fourth power. And then we go to our table, right? X raised to the fourth power, what is the value? Well, 2 is 16, and 3 is 81. Holy smokes. And 4 is 256, and 5 is 625. We don't need any bigger than that, right? So, now let's look. 96. Can 96 to be divided by this? No. Can this? No. And this? There has to be 16. Let's see. Let's just see. 96 divided by 16. What do we know? 96 divided by 16. Hey, it goes in there evenly. 16 times 6. Now, do we know the fourth root of 16? Yes, we do. The fourth root of 16 is 2. Do we know the fourth root of 6? No. So the fourth root of 6 is there, right? Can 3 divide by 4? No. This is smaller than that. That has to stay, right? How about 4 goes into 6? 4 goes into 6 one time with 2 left over. How about 4 goes into 9? 4 goes into 9 2 times with 1 left over. Ta-da! The total and complete answer. That's what we're doing today. How about that? All right. Enjoy. You are ready for your worksheet.